Hi, Dr. Minhao. So I just want to show you the system I finally developed. I spent a lot of time on it. So I just want to show you and ask you about some advices. So basically, the functionalities of this system is almost exactly as we discussed. So to use this system is that first, you create test cases, you create a valid test cases for this system, then you build your code, then you run the visualizations. So let's try the first step. Let's create the test cases. Right now, there's no test cases, so you can see the build button doesn't is disabled. Um, so you must create test cases to build your algorithm. So let's build one. So then this is the uh, test cases creation page. So basically, you for this algorithm, the input is required to be an undirected uh, connected graph. So in short words, that for example, like I'm creating this can be called a graph, but it's not connected because there are nodes or that doesn't belong to the same graph. So you can see that right now I cannot create these test cases, and when your mouse hover around the creation button, it will also tell you why. So to make this one valid test cases, I can just connect the nodes to the graph. Now you can see the creation button becomes valid again. And also there are some other functions. If you made a mistake, you can also undo the changes. I'll just do that. And if you don't like this test case, you can delete it, and you can also change the size of the node and the width of the edges. So right now, I just want to create these test cases. Okay, so here is the visualization. The second step is build, but actually the system will build that automatically for you. And you can also notice that you can build this right now. Um, the build button is enabled again. So for example, I'll show you something. For example, basically this is just like an online IDE. If I right now it's valid, but if I delete this line of code, for example, uh, the bridges will be undefined. So the later code should not be works. Let's try is that true or not. Okay, when I build it tells you that bridges is undefined. So basically, and it won't compile and it won't realize. So let's put this back. Let's build again. Okay, now it works. Um, okay, let's go to the third step, that is realization. So I will explain to you how these visualizations work. Basically, how this algorithm works is that it assigns each node several values, and those values are like ID and low ID, and it also has a node ID, but it's not important. Um, it's not very important. So those data I highlight here. I just want to keep the code clean, so I hide them all the data here. So basically, how this algorithm works is that since each node has these values, so this algorithm will do a depth first search, um, start from any node in this graph, and it keep updates these values of each node until it saw that uh, these three values meet some certain kind of condition. It will yield that I find critical connections. I add that to the answer array. So that's basically how this algorithm works. And on the left is the panel is the legend. It tells you uh, what does each each shape or color means. So basically, each shape and color is associated with the state of node and edges. So let's see. So also I also add a function. Oh, I I also add a function that when you visiting or you're going to do something, there will be a pop-up to tell you what is it is going to do. Um, so let's see. For example, this hasn't been visited, it goes visiting the next node. And we go to the next recursive call, and I'm visiting this node. But actually, that node has already been visited, so it stopped visiting that node, that that edge. Yeah, it's something like that. And basically, the highlighting edges or nodes means that they are currently being visited. Yeah. Okay, right now I found a critical connection. Let's see how it finds that. So basically, this is the step that it finds a critical connection. As I said, so nodes 2 and node 3 both have these three values, ID, low ID, and node ID. So now these two nodes values meet this certain condition, and so the algorithm will yield that okay, I found this edge is a critical connection, and also this step is corresponding to the code that is highlighted in the code editor. Then on the visualization, it will cover it as the critical connection colors. So that's basically how this system works. And you can also change the play speed. So okay, there's another thing I want to show you is that since each node has all different values associated to that, so you can also switch to different showing mode. Right now I'm showing the ID value. I can also switch to show the node ID. Okay, this step they are all the same. Let's move to the back. So right now the node ID is this. Right now this realization is showing each node's node ID. I can also show each node's ID value. Right now they are all none. And also the low ID is something special. It's related to algorithm. So basically it means that the lowest node they can reach. So I use the blue arrows to show that. For example, the arrow between 1 and 0 means that the lowest node from 1 can reach is 0. That means that I can also disable that. Yeah, that's how this system works. Also, since right now this test case is a one with that has a critical connection. So now, right now, I want to test whether my algorithm works on a graph that doesn't have a critical connection. So, uh, so right now I'm just creating a circle. Uh, So we all know that this one shouldn't have a critical connections. So let's see how this algorithm works. Let's speed up this realizations this time. Oh, sorry. Okay, it finishes and it doesn't find any uh, critical connections. So yeah, and I can also change back to my first test cases. I can switch test cases. to play with that to make sure that my algorithm is definitely general generic, that it can apply to any test cases. Yeah. So this is how my visualization system works. I just want to show you and ask you some advices. And thank you. Uh, hope your tools be better soon. How to stop this?